Spotting bias. Sometimes data may be generated, selected, or analyzed in such a way that it favors one group, outcome, or conclusion. This is called data bias. Bias is another way to describe prejudice, partisanship, or favoritism. The Australian Association of Mathematics Teachers, AAMT, has identified several ways researchers can introduce bias into their data, including using survey questions that are constructed with a particular slant, choosing a known group with a particular background to respond to surveys, making non-random selections when sampling, committing systematic measurement errors. Let's examine these individually. Slanted questions. Questions constructed with a particular slant might use a leading phrase to predetermine the response, such as, "Where do you enjoy drinking beer?" This question presumes that the respondent drinks beer. Choosing a known group with a particular background. A study attempting to report on public perceptions of the economy as a whole, but distributing a survey only to homeowners introduces demographic bias to the data. By excluding people who live in apartments, the study may not offer a complete picture of public opinion. Non-random sample selections. Random sampling enables a survey to be distributed to a small number of people representative of a larger population. A simple random sample is meant to be an unbiased representation of a group and is considered random when each member of the subset has an equal probability of being chosen. An example of a simple random sample would be drawing the names of 10 students out of 50 in a hat. In this case, the population being studied is all 50 students, and the sample of 10 is random because each student has an equal chance of being chosen. Non-random sampling occurs when you only distribute your questionnaire only to your friends on Facebook or to the first 10 people who arrive at an event. In both of these cases, the survey recipients do not have the same probability of being chosen as the others in the population they are meant to represent. Systematic measurement errors. Systematic measurement errors occur when data is not measured consistently. For example, a study of the height of a population that includes measurements taken when respondents are wearing shoes with soles of varying thickness may not be accurate, or the weight of research subjects taken on scales that have not been calibrated for accuracy. Bias can be unintentional or deliberate. All authors have subjectivity, a background that influences their opinions and ideas, but if an author is not careful, he or she may introduce steps in data gathering and analysis that produce an incomplete picture of the facts. When evaluating a visualization, consider who gathered the data being represented, who created the visualization, and what was the author's message. Going back to the drone visualization from earlier, reflecting on the story being told there, what could be missing from the data communicated to you, the viewer? What do you think the author's purpose is in highlighting the point in time when President Obama was elected to office, and then a rapid display of drone strikes? Is there a larger narrative here? Were there more drone strikes because Obama was in office? Or can there be an unknown third factor that was responsible? Were there other historical factors? Or did drone technology become more effective or less expensive? Are the authors of this visualization presenting the data in a way that is inevitably leading you to a specific conclusion?